This video is for the practice test. Now, one thing to note about the practice test compared to the test. This says solve the quadratics, so it doesn't tell you which way to solve. However, on the test, if it cannot be solved by factoring, it will say use the quadratic formula. However, so saying that, these first two questions cannot be solved by factoring, so we need to solve these using the quadratic formula. First thing you have to do is move over this 3. So this is x squared plus 6x minus 3 is equal to 0. Always first set equal to 0. So a is going to be equal to 1, b is equal to 6, c is equal to negative 3. So when I'm doing this, I have my opposite, b, plus or minus. A lot of times people forget this plus or minus, the square root. Make sure this is in parentheses, b squared minus 4 times a times c, the whole shebang over 2a. So this is equal to negative 6 plus or minus the square root of 48 over 2. Now, depending on how you want to solve this, you have to simplify the square root of 48. So that would be 4 times 12. This is 2 times 2. This is 3 times 4, 2 times 2. So here's a pair of 2's, and here's a pair of 2's. So I can simplify this because a 2 comes out here, and a 2 comes out here. So both of these 2 get multiplied on the outside. This 3 is left inside. That 3 is left inside the root. So what I have here is negative 6 plus or minus. This becomes 4. 2 times 2 is 4. Square root 3 over 2. This is where I look at my heart. So what do all of those divide by? They all are divisible by 2. So if I divide each of these by 2, I get 3 plus or minus 2 square root of 3. You could have this over 1 if you want. You don't have to, though. So the second one, this one already has that it's equal to 0. So now I just have to say my A, B, and C. So A is equal to 4, B is equal to 10, C is equal to negative 3. So opposite B plus or minus square root. Look at how I'm putting this in parentheses. B squared minus 4 AC. That whole shebang. Notice how I'm doing the whole thing. A lot of times people forget about that side. 2A. So this becomes negative 10 plus or minus the square root of 148 over 8. Again, you have to do your factor tree. So if I do my factor tree here, this would be 4 times 37. So 2 times 2. So here's a group of 2's. 37's prime. So 1, 2 comes out. I'm left with the square root of 37. So that would be equal to negative 10 plus or minus 2 square root 37 over 8. If I look at my heart, they're all divisible by 2. So this answer would be negative 5 plus or minus. You don't need to have that 1 there, but you sure can if you want to. The rest of these are factorable. Now, just so that I do one still factorable, I'm going to factor the rest, but I'm going to do this one using the quadratic formula. So first I have to do is add this over. So I'm going to add this over, and I get 3x squared plus 25x plus 42. This is equal to 0. Actually, I'll do a different one with the quadratic formula. I can factor this. So looking at this factor, I'm going to factor this using the box method. I'm going to do a couple different ways. So this one I'm going to do by the box method. So if I'm going to factor this, so my A term gets in the first and my C term gets in the last. We have to figure out these two numbers. So again, first you multiply these two together. This would give me 126x squared. So I have to find my factors of 126 that will add. So they have to add to 25x. So it just so happens I already know my two factors are 18x and 7x. Otherwise, I would write them all down because these two add to 25 and they also multiplied to 126. So now I look at what do these two have in common? 18 and 42, they're both divisible by 6. Here, these both have an x's in common, so I can take out one x. 18 and 3, I can take out a 3, and there's an x here. And here, these are both divisible by 7. So I have a 7 outside. So this factored is x plus 6 and 3x plus 7. So I set both of these equal to 0. So I set this equal to 0 and this equal to 0. I subtract my 6 here. Here I have to subtract my 7 and then divide by 3. So my answer here would be -6 and -7/3. Next one, I'm going to use a different color just so that you can see it. So now I'm going to still factor, but I'm going to factor by guess and check. So when I guess and check here first, I have to add this over. I don't like my x squared to be negative, so I'm going to add this over. So I'm going to have a positive 4x squared. I still have to write this in standard form. 18x plus 20 equals 0. First thing I notice is that all of these are divisible by 2, so I'm going to factor out a 2. So I can take out a 2 out. This is 2x squared minus 9x plus 10 is equal to 0. So now I'm trying to get so it looks like something like this. So when I'm going to guess and check, my only options for 2 are 2 and 1, 1 and 10, and 2 and 5. So I'm going to guess and check. Notice how I still have this 2 over here, but this is just where I'm going to guess and check so that I can kind of know what's going on. So I can clean up my 2x with 2x and x. I'm going to guess and check 5 and 2 first. So I'm not going to put the 2 here because the 2's would have a common factor. I'm going to put the 5 here, and I'm going to try to put the 2 here. So they both have to multiply to get a positive 10. Looks like. So check my outside. I get a 4x. Inside, get 5x. So 4x plus 5x gives me 9x. Does that work? No, because it should be a negative 9x. Well, I can multiply -2 times -5, and that will still give me a positive 10. And now when I change these to negative, this gives me -5x and -4x. So now that gives me a -9x. So now that checks out. So I'm going to have this factor as 2x minus 5 and x minus 2. This does not have an x with it, so I do not have to set that equal to 0. I set the 2x minus 5 equal to 0, and the x minus 2 is equal to 0. Here I add over my 5 and then divide by 2, so this would be 5/2. Here I'm going to add over my 2. So my two answers would be 5/2 and positive 2. And, oops, sorry, it was kind of off the charts. And the last one, I'm going to do this one, even though I can factor this, I'm going to do this one using the quadratic formula because I know some people still like to do that using the quadratic formula. So I first set out what my a, b, and c are equal to. A equals -2, b equals -5, c is equal to 3. So opposite b, plus or minus the square root. Again, notice how I put parentheses, -4 times a times c, all over 2a. And then this is equal to 5 plus or minus the square root of 49 over -4. Well, the square root of 49 is a perfect square. And again, the perfect square means that it could have been factored. This becomes 5 plus or minus 7 over -4. So I have to split this up because of this perfect square. So I'm going to do 5 plus 7 over -4. Now this division, this fraction bar is like a parenthesis. So you have to do that first. If you are plugging this into your calculator, you have to put this in parentheses. And my two answers here, this becomes 5 plus 7 will be 12 divided by -4, which is -3. 5 minus 7 would give me -2 over -4, which is 1/2. So my two answers here should be -3 and 1/2. And if you would have factored this, your two factors would have been x plus 3 and 2x minus 1. That would have been it factored. So again, I'm still at the part where I'm going to be solving. I could subtract this over. I could use the quadratic formula, and then b would be 0 because there's no x term. However, because there's only one x squared here, I'm going to solve this. So I'm going to first try to get this x squared by itself. So I'm going to divide both sides by 3 and get x squared is equal to 7. Now the opposite of taking something squared is taking the square root. This is where you have to be careful. There are two answers here because if anything squared is always going to be positive. So we have two answers here. So x would be equal to positive or negative. You can't simplify the square root of 7, so it'd be positive, negative, square root of 7. Again, you could use your quadratic formula here too. This should still be your answer. Same for question number 7. You can use your quadratic formula here, and then 0 would be c. Here, there's no x term, so 0 would be b. Here, 0 would be C. I'm not going to do it that way. I'm going to factor because I noticed that they both have a 5 and an x in common. So I can take out a 5 and an x, leaving me with x minus 2 is equal to 0. Now, because of this variable, now I would set both of these equal to 0 and solve. Here I divide by 5, so x is equal to 0. Here I would add my 2. So my two answers are 0 and positive 2. Moving right along. It's telling you should have I. It's telling you right there. I can break this up as the square root of -1 and the square root of 144. The square root of 144, if you're not good with your perfect squares, test this first in your calculator. Not this, because it will say that's unavailable. But the square root of 144 is 12. And because I have the square root of -1, that's always symbolized with my I. What's the difference between this and this? Here I'm solving, so I need a plus or minus because I don't know what x is equal to. Here I'm simplifying, so there's no plus or minus there, no plus or minus. Question number 9, it's adding here. So because of the adding, I am just going to take away my parentheses from my two imaginary numbers. Now I can combine like terms. So here's my real part, here's my imaginary part. So 1 minus 4, -3. 6i plus 2i, 8i. So that would be my final answer. Here, you have to distribute my -1. Once you do this, the parentheses are gone. So I have 2 minus 5i. This is -1 times 3, so that's -3. -1 times positive 4i would be -4i. And now it's the same type of question. Here's my real parts. Here's my imaginary. So this becomes -1 minus 9i. 9i. Now we have to get rid of the I in the bottom of the fraction. First, you have to be able to tell the difference between these two. This imaginary number is built up of a real and imaginary part. This one just has the imaginary part. We're just looking at the divide by, the denominator of the fraction. When we have a real and imaginary part, we have to multiply by the conjugate. So the conjugate here is always the bottom. So this becomes 4 and an I. Whatever's on bottom has to be still on top. Because this is subtraction, we need the conjugate to be adding. So now when I'm adding, or when I'm multiplying, look how I'm multiplying in between. You multiply the top and you multiply the bottom. So I have my first, this becomes -4. Outside would become a positive, that's a negative. This becomes a -I. Inside right here becomes a plus 12i, and my last becomes a plus 3i squared, because I times I is I squared. On bottom, I multiply across, so 4 times 4 is 16. 4 times I is a positive 4i. Negative I times 4 is -4i. Negative I times positive I is a negative I squared. This is where you have to know what to do. Okay, so I'm going to combine my like terms here. I'm also going to change my I squared to a -1. So on top, I'm going to have -4, -I, plus 12i would give me a plus 11i. This becomes 3 times -1, because I squared is equal to -1. On bottom, I'm going to have my 16, 4i minus 4i, that cancels. Now I have a minus, and again, I squared is equal to -1. So what I have actually, this becomes a positive 3 because it's adding. 3i times -1 is -3. -1 times negative, this becomes a plus 1. So my actual answer then, when overall said and done, I can combine these two. -4 minus 3, this becomes a -7 plus 11i. And on bottom, this becomes 17. So my overall final answer looks like this. Compared to this question, question 12. Now I just have the imaginary part. If I want to get rid of that imaginary part, I have to multiply it by I over I. So I distribute. So this becomes 2i minus 5i squared. And this is whole multiplying. So I have 6i times I is I squared. So again, this right here, I squared, becomes a real part. So I have 2i minus 5 times negative 1 over 6 times negative 1. This becomes negative 5 times negative 1. If you leave your answer like this, I will still accept it. However, that's not really proper. You should have your real part first, your imaginary part second. You could also write it like this. These two are the same answer. And last but not least, oh no, not least, it's telling you to use the quadratic formula. It's telling you right here, saying your answer should have an I in it. So my A is equal to 1, B is equal to negative 2, C is equal to 10. So opposite B plus or minus the square root of B squared minus 4A, C, all over 2A. If you put that one part in your calculator, you should get that that's equal to negative 36. So 2 plus or minus the square root of negative 36 is equal to 2. This right here can look like the square root of 36 times the square root of negative 1. Now this becomes 2 plus or minus 6i, because the square root of 36 is 6, and the square root of negative 1 is I. You have to look at your heart. Bum, 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 bum. And all of those numbers are divisible by 2. So 2 divided by 2 is 1, plus or minus 6 divided by 2 is 3. You still have that I. 2 divided by 2 is 1. You don't have to have the over 1, but you sure can if you want to. And there it is, you guys. See? Bing, bada, boom. You're going to ace this test. Ace in the face. Have a great, grand, wonderful day.